Today we're going to talk about the Pythagorean Theorem. So in a right triangle, the sides that come together to form the right angle are called legs. The side opposite the right angle, which is always the longest side, is called the hypotenuse. So this happens when we have right triangles. And it's important to remember here, we're talking about right triangles. So again, when we look at this next diagram, it kind of shows where these things are. It shows where these are. Here is a leg. Here is another leg. Notice how they come together here to form the right angle. Remember, the right angle box here tells us that we have a 90-degree angle. If I go directly across from that right angle, there is the hypotenuse, which is the longest side. So the hypotenuse is our C value, which we're going to be talking about in a moment. And the legs can either be A or B. They don't really matter which one you call the A or which one the B. The A and the B ones, though, are always the ones that come together to make the 90-degree angle. So here's the Pythagorean theorem. For any right triangle, and again, it's important that we recognize right triangle, the sum of the squares of the length of the legs. So we know sum means to add. Squares means that I'm going to take each leg and square them and then add them together. We know that equals tells us the equal sign. So the sum of the squares of the lengths of the legs is one side of our equation. The square of the length of the hypotenuse is the other side. That would be the C, or the longer side. So in algebra terms, this is where we have our equation that we're going to work off of. There's one leg squared. The sum, there's the second leg squared. That's the first one. And on the other side, the square of the length of the hypotenuse. C is always the hypotenuse, and maybe more of a practical thing, the longest side. So even if I gave you three sides of a triangle and didn't even give you a picture, and we told you that it was a right triangle, you could still use the hypotenuse, knowing that it's the longest side, and plug it in. Now, what you'll also notice before we start working on a few of these examples, the Pythagorean theorem is not talking about angles of our triangle. What it's talking about is the lengths of the sides of the triangle. So yes, we do need to know one of the angles because we need to know it's a right triangle. But really the hypotenuse and the two legs are sides. So the Pythagorean theorem is really trying to help us find sides of a right triangle, not angles of a right triangle. So here would be two examples, and let's just see how this works. So you don't see any pictures here. For some reason the pictures didn't download. So I'm going to draw them in first, and then we will take a look at that in a moment. So here we have two triangles, obviously not drawn as well as your note sheets would have. But here are the two triangles and the size that they were trying to get us to see. So they're finding the length of the hypotenuse of the triangle. They've labeled them as C's to kind of help us understand how the formula works. You're not always going to have it that way, but just for now we can just think of them as C's. They could just be labeled as X's or any other number. It's important just to recognize which one is which. Okay, so we're going to use our formula. A squared plus B squared equals C squared. And now we're going to fill in what we have. Well, we have one of our legs right here. We have another leg right here. And the hypotenuse, remember we said, is across from the right angle. So for the moment, we don't have that one. So we're going to use our regular PEMDAS steps to put together and simplify the left-hand side, and then we'll use our SADMAP steps to solve for C. So we get 7 squared That's 49. 24 squared is 576. That still equals c squared. I can add together those two to get 625 to get c squared. Now, to undo a square, we know that we just take our the situation we have and take the square root. So remember, to undo something squared, we do our square root. At this point, we take c, because the c squared, the square root is c. On the other side, we would have 625. When I take the square root, it would have both positive and negative, because I'm just taking the square root, because negative 25 times negative 25 is also 625. But I'm not going to count the negative, because we would never have a side of a triangle as a negative number. So we kind of throw it out. Our answer is 25 centimeters. On the second one, so again, we have our formula a squared, b squared, c squared. We have our legs, so another 7, this time a 10. And we're trying to figure out what a c is. But again, the c is across from the right angle. So I'm just going to continue with this and say 49 plus 100 equals c squared. I use my regular PEMDAS here to put these together. Now at this point, this is where we say, now I can take the square root to get c by itself. Now the square root of 149, we don't know that number. It's not a perfect square. It's someplace between 12 and 13. We're going to use the calculator. Again, we only want the positive answer on this one, and it is about 12.2. So our better answer is to say it's approximately 12.2 inches. So here are two more examples. We'll kind of go through these two a little bit quicker. Again, we want to think a squared, b squared, c squared. We want to know what we have. So we have a leg here and a leg here. So 5 squared, 12 squared. The side across is the c. That's the one we need. So we get 25 plus 144 equals c squared. 169 when I add together those two. And again, to undo c squared, we take the square root, and we get c equals 13. So in this case, our label is 13 meters. On the next one, we want to get in the habit of just write out the formula or the equation first, then plug in what we have. Well, we have another a and a b, because those make the 90 right angle. So that's going to give me 8 squared plus 15 squared. And on the other side from that is our c squared. That's going to give me 64, 225, 64 and 225 is 289 equals c squared. Again, we then take the square root of both sides. That's going to get us to the c that we need. And the square root of 289 is 17. So our answer is 17 feet. Okay. Now when we look at these next two, very similar, same exact kind of setup. We just got to look at the information we have to figure out what we go from next. So here we're going to say a squared plus b squared equals c squared. We're looking for the length of a side. Notice though on this time, so what we have for information, we have one of our legs, and then we're going to square that. Over here, the other leg we don't have. I'm going to leave that as a squared now. And then notice what we do have here is 2.9, which is our hypotenuse squared. So what we have to notice here is that these numbers are obviously on the opposite sides of each other versus the other ones that we did where they were all the same. So you're not always going to get both legs and then find the hypotenuse. In this case, we have a hypotenuse in one leg, and we're going to look to find the other one. So what we're going to do is we take care of what we have. 2.1 squared is 4.41 plus a squared equals 2.9 squared is 8.41. Both done with a calculator. So now I got to think SADMET. So again, remember, we're trying to get this a by itself. So we have an exponent with it and an addition with it, which means we take care of addition first. So I'm going to subtract 4.41 from both sides to get us to the next step. That will help cancel out the next piece. So it leaves a squared by itself on the other side of 4. Then we would then take the square root to undo the a squared, and the answer would be plus or minus 2, but we don't really care about the minus 2. So in this case, that would tell us that the leg is 2 centimeters long. Now again, if somehow I did something wrong and this 2 centimeters was bigger than 2.9, that would tell me something is not right, because remember 2.9 has to be the biggest side or the longest side because it is the hypotenuse. So over here on this last one, again, a squared, b squared, c squared. What do we have? Well, we don't have this one, so we'll leave it as the a squared. The other leg we do have, and in this case the hypotenuse we have. And it's just important that you put them in the right spots. Oh, we got a square, the 99.6. So again, we're trying to get a by itself. So the first thing I do is say 9.6 squared, 10.4 squared. Well, 10.4 squared is 108.16. 9.6 squared is 92.16. We still have just the a squared. Again, we're trying to get this a by itself, so I've got to move the 92.16 first. That's going to leave me with a squared and a 16. Then, when I take the square root to get a by itself, that gives me my answer of a equals 4. And again, it has to be smaller than 10.4 for sure. And it is, obviously. So 4 meters. So the Pythagorean Theorem is going to help you in a lot of different ways. Lots of situations pop up with right angle type situations. You have to make sure you have a right triangle to be able to use it. It does help you find lengths of right triangles, and it can be very useful. Just make sure that you are plugging in the a and the b as your legs, the things that form the right angle, and the c is always the hypotenuse, which is the longest side or the side that's on the opposite side of the right angle.